All right. The first thing that we have to realize is that if we have got a vector, we say for vectors that they exist in xy plane. ठीक है. So let's draw xy plane first. Here is y-axis. Here is x-axis. Let me fine tune it a bit. Okay, and then this is like this. ठीक है जी. In this xy axis, let's draw a vector. Here is my vector. Fine. Acha ji. So this vector, I can give the magnitude of the vector. So usually for vectors, we have chosen a scale, and based on that scale, we have got the that scale. It represents the magnitude of the vector. ठीक है. And the other thing that we need to know about vector is that vector, it needs to have a direction. So I can define direction of this particular vector either with respect to x-axis or with respect to y-axis. ठीक है. Let's do first with respect to x-axis. So let's say that this is making an angle theta with the horizontal. So far so good.
जी सर.
All right. So if this vector is making this, I can say about this vector, okay, what's happening is that there is some component along x-axis and some component along y-axis. So this much is the component of this vector along x-axis, and this much is the component of the vector along y-axis. Okay. So if I have to go from point A to point B, I can take two paths. One, I can take the path of the vector. The other path I can take is I move the x component first and then the y component, right? So that's the whole vector. This x component of the vector, I will call it fx, and this, sorry, v is my original vector, so I'll call it vx. My original vector is v, so I'll call this one vx, and this y component over here, I will call it vy. Any problem in this?
No, everything's understood so far.
Okay, if you could also please draw the diagram along with me, so things would become a bit easier. So if you could just draw this much and then let me know that you have drawn, and then I'll move forward with further explanation.
ठीक है.
All right. Now I can see that this diagram, it represents a right angle triangle. So I can say sine theta is equal to opposite by hypotenuse. Opposite is what? Vy. Hypotenuse is what? V. Yes, madam. So rearranging it, I get V sine theta is equal to Vy. So if I want to calculate the vertical component of this vector, I can say I need to know the original vector. I need to know the angle that it's making with the horizontal. And if I calculate V sine theta, I would know the component of the vector that is along y axis. Agreed?
जी.
Acha ji. Similarly, I can also say that uh, I can also say that v cos cos theta. Okay, so cos theta will be equal to adjacent by hypotenuse, so vx by v, and rearranging it, I get v cos theta is equal to vx. This is the component of the vector along x-axis. If I need to know what component is Acha, this vector, it can be any quantity. It can be velocity, it can be force, it can be acceleration, any vector quantity at all. It can be resolved this way, that I can find its x and y component. Understood?
Could you
G.
repeat
So
it?
over here, I just took a generic name vector, and I've been explaining that this is a vector. Practically, we can use any vector quantity to find the y component of that vector quantity and x component of that vector quantity. So all the vector quantities that we have got, force is a vector quantity. So this v, it could be a force. So for example, I could have had a force vector f over here. I could have a velocity vector v. I could have an acceleration vector A. So it would, what we are learning over here, it would work for all vector quantities. For momentum, we would soon see that it also works. Okay, so any vector quantity at all, it can be resolved into its vertical and horizontal component this way. Okay.
ठीक है.
Okay. One more thing that I can do if I'm given the vertical and so one thing could be that I'm given the vector and its direction. The other thing could be that instead of giving me the vector and its direction, I am given the components of the vector. So something it moved along x-axis this much, it moved along y-axis this much. So they asked me to calculate the vector by giving me the components. So I can do that too. For that, what I'll do is I'll again use the right angle triangle uh, properties. So I can say first of all, v squared is equal to Vx squared plus Vy squared. And if I want to calculate V, it will be equal to square root of Vx squared plus Vy squared. Agreed, madam?
जी.
Acha ji. Similarly, if I want to find direction, while I'm given the perpendicular, the vertical and the horizontal component of the vector, I can do that too. So I can say tan theta is equal to opposite by adjacent, so Vy by Vx. And if I need to find theta, it would be theta is equal to tan inverse of Vy over Vx. Yes, madam. So this way I can find the angle that it is making with the horizontal. Understood?
ठीक है. जी, जी.
Acha ji, if you could note down till here, then I'll give you the next thing.
जी.
Yes, madam, noted.
जी.
Acha ji, right now what I had done was based on the information that the angle given for the vector is from the horizontal axis. But it's equally true that I could be given the direction of this same vector from vertical as well. So what if the angle that I'm given is what this vector is making with the vertical. So I'm given this angle alpha over here, right? So I'll now have to calculate the same vertical and horizontal components of this vector. So it would be like this. This would be the vertical component, and this over here will be the horizontal component, the purple one. Yes. So let me label them as well. This would be Vy and this would be Vx. Okay. So now the triangle that we are considering is the original black vector along with the purple components, right? Yes, madam.
ठीक है. या.
Acha ji. So now if we break down the triangle, so we can say sine theta is equal to opposite, or instead of theta we'll have alpha. So sine alpha is equal to opposite by hypotenuse. Opposite is Vx and hypotenuse is V. So if we solve it out, it would become V sine alpha is equal to Vx. Yes.
ओके.
And similarly, if I did something for cos theta, I would get uh, cos alpha is equal to adjacent by hypotenuse. Adjacent is Vy and hypotenuse is V. So V cos alpha is equal to Vy. So you must be thinking, why did we do this thing? Madam, the reason for that is that most of the times the angle that you would be given for vector would be from the horizontal axis. But that's not mandatory that you'd always be given from the horizontal axis. You could be given, I mean, all you have to do is to define the vector. So that vector, it could be defined with respect to the angle it is making with the x-axis or y-axis. It would be equally valid description. Yes, madam.
ठीक है.
If I have to give direction of a vector, I can give direction with regards to x axis, or I can give direction with regards to y axis. It's not mandatory that I have always to give it with regards to x axis, even though most of the times, most of the questions that you would get, you would be given the direction from the x axis. All right. Acha.
जी.
So the point to remember is that some students what they do is they end up just memorizing that Vx is equal to V cos theta. Yes, that would be true in most of the cases, but it would be true always when the angle is given with respect to horizontal. If the angle is given with respect to vertical or the y-axis, then the same x component it will be given by sine alpha, V sine alpha. Got it, madam? So in both
जी.
cases, I'm calculating Vx. In one case, it's coming V cos theta. In other case, it's coming V sine alpha. It depends on which angle is given. Is the angle of the vector given with respect to the horizontal or the vertical? Most of the cases, the angle that would be given is with respect to the horizontal. That I agree. But we must know that the other equation could also be true. Okay.
Yes, sir.
ठीक है जी. Any confusion till this point?
No, everything is understood.
Achha, if you could note it all down, then I'll move forward with the next thing that we need to discuss. All right, let's now apply this to the case of projectiles. Madam, projectile is ke I've got a body, let's say a football. Okay, the football is lying here on the ground. ठीक है, ये मेरे पास यहाँ पे एक football रखी है. Now what we do is ke a person comes and kicks this ball and gives it a velocity at an angle theta to the horizontal. Yes, madam.
ठीक है.
We know that this ball it would follow a projectile this inverted parabola like path. Yes, it would move forward, it would go up and it would come down. Yes, Acha ji. So the other thing we have to remember is that we know Newton's first law, law of inertia, that a body would continue if a body has velocity, whatever that state of velocity is, whether that velocity be zero, whether that velocity it has a certain value, the body will have the tendency to continue this state of velocity until some force acts on it. Okay, so the velocity would only change if there is force on it. Velocity it would change only if force acts on it. Do we agree on this statement?
जी.
Acha ji. Now we will make a slightly more enriched statement. Now we would say that this velocity it's at an angle. So this velocity has got two components. It has got a horizontal component. We'll call that one Vx. And the same velocity it has got a vertical component Vy. So the two components of the velocity are Vx and Vy. And only the component on which the velocity on only the component on which the force acts, only that component of velocity would change, not the entire velocity. So if force acts along a component, only that particular component of velocity would change, the other component of velocity will not change. Okay, is this statement clear?
जी.
Acha ji. Let's describe this whole parabolic motion so that would make the statement even more clear. Acha, we usually for these questions of motion, we say that there is no air resistance. So if we ignore the air resistance and we move forward, is there any force which is resisting the forward motion of the ball? So if there is no air resistance, is there any force which is opposing the forward motion of the ball?
नहीं.
No. So
No,
through
no. Gravity is there.
gravity is vertically. So gravity, it would pull the ball down.
Friction कुछ.
Air friction, there is none. There is no air resistance. It's moving in air. It's not, rolling on a surface. So there is no surface friction.
Hmm.
And since it's in the air, for air we have said there is no air resistance. Okay? So there is no force which is
Okay.
opposing the forward motion of the ball. So throughout the projectile, the Vx component, it would stay the same. It would maintain its initial value of Vx. Got it, madam?
जी.
Acha ji. As for Vy, since the gravity it is pulling the ball down, this Vy, it would lose its value until it gets to the top, where Vy, vertical component of the velocity, becomes 0. And how do we know that the vertical component of the velocity has become 0? Because if there were any more vertical velocity, the ball would have gone further up. The ball
Hmm.
stops going further up because there is no longer a vertical velocity which would make it go up. All right, madam. So at maximum height, so this we learned at maximum height in the projectile motion, Vy is 0. Okay. And then as the ball it comes down, the velocity, it would keep on increasing until it finally hits the ground. So it has regained the original value of vertical velocity with which it was launched. Understood?
Hmm. ठीक है. But it's in the opposite direction.
It would be in the opposite direction. Yes, that's also a very good point to note. Okay, in vectors, we give importance to direction. So upward direction, if we're taking as positive, the downward direction we'll take as negative. But the thing is, we know in order to calculate the final velocity, v, we just concluded if we are given the components, it would be vx squared plus vy squared. So even if it were negative, squaring it would again, uh, ignore the
Hmm.
effect
जी
of
जी.
it being negative and would give you back the same velocity.
सही. ठीक है.
Okay, this is what we need to remember for projectile motions. Acha, shall we take a break over here? Let's say 5 to 10 minutes.